We will begin from what we will discuss today. The topic is advanced multithreading in Kotlin Multiplatform, and at first we will talk a little about Kotlin Multiplatform and talk more about common concurrency in Kotlin Multiplatform. Also, we will speak about coroutines as the main way to implement concurrency in Kotlin Multiplatform and how to solve problems in Kotlin Native. We will focus in Kotlin Native because with Kotlin GVM that is used for Android applications is everything okay. Also, we will speak about concurrency without coroutines. I think it is most important for advanced multithreading, and we will speak about workers, advanced sharing, and also we'll speak about Kotlin Native and how it deals with flows, and especially how it deals with flows in iOS side. Let's begin. Many Kotlin developers know what is Kotlin Multiplatform is, but not everyone is familiar with it. So Kotlin Multiplatform is a SDK for cross-platform mobile development, and not only mobile development, by JetBrains company. The main idea of Kotlin Multiplatform is to keep some common code. It could be several services implemented in a common way with common structures, common data structures, common architecture, to keep all this common code in some shared model and use it as a library with Android, iOS, and several supported platforms. Kotlin Multiplatform is SDK. It is not framework at all. Because there is only logic to deal with common business logic, common structures, and not to deal with UI. You need to deal with it in your native applications. Also, it allows you share almost everything. And one more thing, it compile all the models to compatible for all the platforms code. For example, it uses Kotlin GVM to compile to Android bytecode and LLVM in Kotlin native for iOS. So it is one of the most specialities of Kotlin Multiplatform. It uses own version for every platform it supports. For example, it uses Kotlin GVM for Android, and it is the same GVM you use for Android development at all. Also, it uses Kotlin JS for web development and Kotlin native for iOS or some desktops. And we understand that a main point, Android and iOS, we will speak about mobile, not all the Kotlin multi-platform. Android and iOS are different in its native part, and also concurrency in Kotlin GVM and Kotlin native is different. And to deal with it from some common points, we need to declare some common components in some common point as expected and implemented differently with actual modifier in Kotlin native side, in iOS main, and Kotlin GVM in Android main. Let's take a look at sample. I think it will be better to use some sample to talk about concurrency, and the most popular case when we in mobile development need to implement concurrency is networking. We will not speaking about animation, some hard UI, because Kotlin multi-platform, it is not about UI, it is only for business logic. So we will focus on networking. We can implement networking in with concurrency in Kotlin multi-platform application in common part with common implementation. For example, using such a network client as Ktor. And to deal with concurrency, we need coroutines. And also we can implement networking separately in native iOS main and Android parts and use as coroutines as native concurrency. It depends on your architecture. Let's take a look at the simplest sample. We will speak about how to deal with networking when we use Ktor and coroutines. It is the most popular case to implement the simple networking with Ktor because Ktor already implemented all asynchronous work under its hood. And we will see later that it uses the same symbols that is common for all advanced multithreading at all. So Ktor has already implemented everything, and we can use Ktor easily. It simplifies the life of mobile developers who deal with Kotlin Multiplatform, and we can notice that Ktor uses coroutines for concurrency. Let's take a look. How can we deal with it? If we will call a network client that implemented request to Ktor from our IO site directly, we shouldn't use anything extraordinary to implement some additional concurrency work, because all suspended Kotlin functions will easily transform into Swift functions with completion handler. It's supported since the Kotlin native 1.4 version. And though Kotlin Ktor is already asynchronous, we shouldn't even put additional routing and dispatching to some queues. So it is not blocking in iOS. In this case, we should deal nothing, and we can also easily call, for example, in Android side from view model native scope. So there is no work for Kotlin multiplatform common concurrency. Let's take a look in another case. We decided to get the most experience of shared architecture, shared working in Kotlin multiplatform, and we use common architecture that requests to, for example, network service. So we need to implement our own scope in this common architecture to deal with coroutines in network service. What should be done in this case? We need two coroutine contexts that will hold the links to dispatcher's default for background working and dispatcher's main for work with UI. What are these dispatchers? Dispatcher's default is, if we speak about Android, it is default background dispatcher, and dispatcher's main is a UI dispatcher for every platform. It's unique for every platform. And let's take a look how it works. If we got under the hood of dispatchers, especially main dispatchers, we will notice that it contains a special factory to get the special dispatcher for every platform it supports. If it is a platform that is supported by Kotlin Multiplatform, you will receive some special dispatcher, or you will receive exception that it is missed dispatcher in this case. So everything with main dispatcher is fine. Well, let's focus more detailed in Kotlin native, and let's understand that Kotlin JVM is okay because everything is already implemented and there is no problem with Kotlin JVM at all. We will be talking about Kotlin native and its concurrency. In this point, let's try to launch our application, and we will receive some kind of exception. It could be freezing exception, or it also could be exception of missed dispatcher. Why we have received this exception? Because there is no default dispatcher in iOS. We have used default dispatcher when we was launching the request to Ktor from our common model scope. Yes, this is a problem of misdispatcher, and it is also an issue 470 about this problem, and it depends from ticket 462, and this was a ticket about supporting multi-threaded coroutines in Kotlin native. Multi-threaded coroutines in Kotlin native are not supported at the moment, and they are not supported, and this functionality is not implemented because it's really hard to get all the functionality of native iOS Grand Central Dispatch and fully transmit to Kotlin native. It's really hard work. That's why it is not implemented at the moment. And there is no default dispatcher for to using with coroutines in Kotlin native and iOS. In this case, we need to create our own coroutine dispatcher and use it as a context with our background and UI dispatchers. Let's try to do this. We can use calling a block of code in several main queue for main dispatcher, and also we should do the same but just like in global queue for background thread. Let's check if it will work. No, it will not work because we cannot route everything in dispatcher queue background because it is not bound to any particular thread. In that case, we have to use main queue as default. Dispatch default will not work in. Dispatch IO is not exist. So, and when we have a deal with Ktor, there is no problem because Ktor is already asynchronous. But it could be several problems while dealing with other libraries, but we will see later that there are several approaches that we can use and implement in our projects. So we will change all the dispatchers in coroutine context to main dispatcher, and then we should add some small command freeze to launch of block of code that will be routed in dispatch dispatch functions of our main dispatcher. Why should we do this? This is because of the rule how to work with threads in Kotlin native and with concurrency. There is a small rule. We can use mutable objects for one thread only, and we can use immutable objects with multiple threads. Yes, it's a common rule for many languages in development, but it's really strong rule for Kotlin native. And in Kotlin JVM, there is no such problems. Everything is already okay. Everything is already implemented and done. Well, to make an object immutable, we should freeze it. We should use freeze command, and if our object was already freezed, it is frozen at the moment, we will receive freezing exception, just like we have received before. Well, also some people advise to try to call background working in this way, but I really doubt because in this sample we call for global queue with priority, but it also causes to some problems because we know that there is no particular thread for them. So there is not a really good example for how to work with background in Kotlin native. Also, we can use global scope. Yes, it seems that global scope is implemented for default background working, but it is not recommended at all because it is a global scope, it is a global coroutines, and basically we cannot inspect the life cycle, observe the life cycle of every job in global scope because it is not bound to any particular job. That's why we can use such fix. For example, we need to hold all the links to jobs that was launched in global scope and then join them by together. And also we need to clear all this list at the end. If we will not clear it and if we will not hold the links, we will get potential leaks and losing of callbacks. It's also a problem. So, and mainly there is why you should not use global scope. It's not recommended by its creators. So, when we have added freeze command to our blog, we have received another problems because What we should do with objects that are already immutable. Singletons and constants are immutable and they are frozen by default. When we will try to free them, we will get such exception. Kotlin Multiplatform advise us to use thread local annotation for such problem to avoid freezing exception with singletons and constants. So we should put such annotation upon the companion object or the object, and in this case we have solved the problem with singletons and freezing exceptions, and everything will be working. Well, it was some really common case how to work with coroutines and concurrency, but it is not really advanced, though thread local is really tricky. We can implement concurrency in Kotlin multi-platform application not only with coroutines. Also, before we will see this mechanism, we should speak about synchronization. Synchronization is used to thread saving with several collections or maybe some variables and read-write operations. And also its difference in Kotlin JVM and in Kotlin native because it's different in Android and in iOS. That's why we need to implement it differently with expect actual modifiers, and it will use monitor in object monitor in iOS, in iOS main part, and Kotlin synchronized in Android main part of your application. Well, and now let's take a look at some other sample. Networking without Ktor and Coroutines. It also could be implemented and easily could be implemented. In this case, we need also background working and some other mechanism to deal without coroutines. And Kotlin Multiplatform uses such mechanism. So we have some interface for our HTTP client. We have two different implementation of this interface for Android and for iOS. And we call these implementations from some point in common code. We should not focus about how we will call this moment. I'm sorry. Let's take a look how we implement work with HTTP client in iOS. Oh, I have forgot to say that in Android it should use OKK HTTP client, and for iOS we will be using simple URL sessions. No extra mechanisms. So here is a simple code for HTTP client. It looks same as we use when we implement native application, with several differences, but mostly the same. Though we shouldn't use Lambda to receive the response from networking, we use delegate. And now let's take a look. What should we do to make it work correctly with concurrency? At first, we need to put all the code that will make the request to network in background, and all the code that we will receive in some delegate listener block, we should put and process in main thread, and then send to some client or maybe some other parts of our applications. How should we implement background working? There is a working mechanism. Yes, it sounds similar, background work and work. So worker helps us to make background working. We need to declare is with worker start, and in this moment worker start listening, and in worker execute block we need to launch our block of code that we will implement it in background. And also we need to keep some links to our worker and to clear it later and to not to get some problems with memory. Well, when we execute some block of code, we use two parameters. First of all is transfer mode for object graph, and we marked that we will transfer all the data safely, so it should be shared or freezed. I use some small extension for Kotlin. It is calling a freeze command, and I just call it share to make it more understandable. So we need at first freeze our block of code, make it immutable, and then we launch it in execute zone. So, and now we will get our working background request in our network client. So what about how to deal with returning to main context? Because we also need it. We can also implement a background worker that supports returning some result to callback. We will add some other parameter as callback block to our function, and then in future consume, in consume block, in consume command of our worker, we need to send the result of worker execution to listener or some other parts of code. Well, here is about how to return the value, but how to switch to main and how to return the value to main. We can also implement in the same way that we used before, sending all the code in and implement it in dispatch get main queue. And of course, at first we need to not to forget to share, to freeze it, because we should remember that before we send something to some queue, we need to make it immutable. We need to share or freeze it. Also, we can try to put this main block in our consume block and to apply to our code. Well, everything was done, but in this point we get exception, invalid mutability exception, mutation attempt or frozen. We should also freeze all the objects we will use in different contexts. For example, we will use delegate, we need to share or freeze the link to delegate. We will use URL session, we need to share or freeze the link to this URL session and then put it in background working. And though we have freezed everything, it still crashes. We have forgot to deal with mutables. What can we do in this case? Let's take a look. How have we implemented saving the data that we receive? When we deal with such things as delegate and we receive all the data we requested, not in the same block we have sent our request, but in some method of our delegate, we need to save it in some storage or maybe bunch to process all the data later. Well, in this case, I used byte array, and when I receive new data, I add the value as bytes to this byte array. And we should notice that byte array was declared in initial thread, and I work with background threading with my new data. And of course, I use what I have declared not in background thread in background threads, and I get invalid mutability exception. I try to mutate frozen. So let's take a look what could be done. We cannot use thread local because it's not singleton, it's not constant, and it could be used only for backend fields and objects. Ktor has implemented their own mechanism of thread local, but it is not thread local as those annotation. It is just freezing, though they called it thread local. So it's already, it's also not the case we need. And if we will remove all freezing, we will also get problem of freezing because it will not working. We will get mutability exception or freezing exception. It's horrible. So in Kotlin Multiplatform, in Kotlin native, there is mechanism of atomic reference wrapper. There is several atomic types, and for objects we need atomic reference to wrap our data. At first we also need to make it immutable, and then we need to keep atomic link to this variable. And of course there is a problem of potential leaks. In such cases there is also a problem of potential leaks. So when we work with such link and we have completed everything, we need to clear it. For example, just put default value without any bytes. And when we need to update the value of such variable, we need to first create in block new variable, new temp variable, put here all the data, all the old data, add new data, and this temp variable we need to save to the value of our default variable, of our declared variable, atomic variable, and not to forget to make it frozen. Well, and it is really working mechanism. Another way to implement sharing is to use detached object graph. It sounds really advanced and something really maybe strange for someone because it's just like a deep dive into the concurrency. How it works? This is a sample from supranational concurrency framework. It's really a good sample how to work with concurrency. What is a detached object graph? You have detached object graph, and in this graph, in memory, you put all in creation all the variables you need. It could be a map of your variables, or maybe some pair, triple. For example, in this case, it could be data for some function, link to this function, and also link to callback for this function. Well, we created a detached object graph, and then we need a pointer to that graph, and we create the pointer before we call it in some thread, and in this thread we attach this graph using this pointer, and then we get all the variables from the structure in this pointer, put the data into the block of function, also result to the callback block, and we send and return the result in the callback, not in this thread but under it. It also working mechanism. It's also really interesting mechanism, but there is one problem. We have to attach only once. If you try to attach same pointer second time, you will receive exception and everything will crash. So you need to create a pointer every time you need to get something in this in some thread. So it's really interesting mechanism, but it could be too complicated. So if it is too complicated, let's return to coroutines. They will help us to return several data, communicate between contexts. Well, coroutines, it's not only about dispatchers and scopes. There are also several interesting mechanisms that could be helpful for us to deal with our functions, our logic, and to return functions between contexts, and also to avoid using too much completion blocks and completion handlers. For example, we can use such mechanisms as channel, flows, and completable deferred. All these mechanisms are supported in Kotlin Multiplatform common model. All of them supported in Kotlin native part. Of course, they are supported for Android. Android supports everything except of Kotlin native. Well, to communicate with channels, we can create, for example, some channel with some size. For example, I use unlimited size. Maybe it's not too much correct, but it is for sample how it could be, how could it work. And also I used several structure for completable deferred because I wanted to avoid of completion handler and to return it with await all the response. Completable deferred for me was mostly a flag when everything was completed, and then after that in channel I produced all the data, and the final data processed with several functions I put in my response and returned as frozen. Not forget to freeze everything. You should freeze the answer also, because if we work with Kotlin native, we need to remember that we need freeze everything. Same with flows, but flow also a asynchronous mechanism, and when we implement listening some data that will be emitted in some flow, we can specify in what scope we need to launch it. Also, I use here completable deferred, but as a mechanism to receive an answer and send an answer as awaitable, and to avoid some completion handlers. And also not forget to clear all the data you use to avoid some potential links. Well, and in my client, I also using such structure, I also use some special scopes, and in this scope that is bound to EO dispatcher, or in Kotlin native, it's also the same dispatcher we used before, also same main dispatcher, also with some job, and because of mechanism of coroutines, it works really asynchronously and everything not crashed, because it is not it will return for me from background work to main work. I mean from background thread to main thread. And also awaitable mechanism it helps to avoid too much callback hell in our code, and also it solves problem with lambda sharing, because if you will try to send the response into the lambda in your request, you will also receive a crash as attempt to mutate something frozen. Well, the flows is not only the way to communicate and hold the data that we will receive from some delegate and send it as with awaitable. It will also be interesting for us because this asynchronous mechanism is alternative to live data, and we can easily use it in multi-platform code. Previously, live data was for Android only, and Flow are supported with Kotlin Multiplatform in common model. And it could be easier. Let's take a look how we could deal with it from iOS side. Because if we implement the work with the Flow in our common model, we also receive we also would like to receive the response in our iOS side in UIB controller as in fragments in Android side. Well, in iOS side it looks really strange because we need to implement some type of collector that should be implemented from Kotlin X Coroutines Core Flow collector, and also specify completion handler. And if for us everything is fine and understandable with completion handler, because we know about suspended and its transformation in iOS side, so there are several problems with collector. We can specify our collector in this way as a class. It holds a link to completion block, or maybe some bunch of data, or maybe some link to your listener. And in emit function, we receive all the values, process it, and then call the completion handler. Well, not too hard, not too much clear. And the problem is sometimes the signal are missed, and there is no and we need more documentation and more information how to deal with it. Well, let's take a look how can we deal with it in other way. For example, we can create some wrapper to our flow. The same code was presented by JetBrains in Kotlin Conf several years ago. In this code, we create a wrapper class that uses flow as default parameter, and also it derived from flow. In collect function of it, we with several scopes that we have defined in this flow collect all the data from default from base flow, and then we send it. So we receive the all functionality of flow, but it is some wrapper that will simplify the calling of this functionality. Or also, it's really useful to implement some cancelable protocol to implement the support of managing of cancellation of such scope. Well, let's take a look how can we call the sample. It is a small sample of just sample flow, and because we have called it not in Coroutines scope, we receive this error. Yes, there was a scope in our collect inside of it, but in iOS we called this code not in scope, and we received the legal state exception. If we will remove the instructions such as flow on, it will not solve the problem at all. So it is not the cause of problem. In this case, we can do several things. For example, we can implement some kind of listener to bind it to our view controller, and this listener will be bound to our view model and receive some signals from our flow, and we will call flow in scope of our view model. Or maybe we need to wrap all the functionality of our flow in some suspended function of view model and call it in iOS side, or we need to make a wrapper on iOS side. Something just like this. I found the statue. I found the article and some sample of code by Miller. It is a nick of GitHub developer. This is a sample how to implement wrapping of Kotlin flow to some kind of Swift combined publisher. Maybe it's really complicated, maybe it's too complicated, but it is a way how we can deal with flows in iOS side. Unfortunately, we cannot manage them directly, and we cannot call them directly to get a normal and correct result. Maybe it will be implemented later in some other versions of Kotlin and Kotlin native. So what should be said in summary? Let's summarize it up. Yes, it could be hard to work with concurrency Kotlin Multiplatform. Such things as atomic reference, detached object graphs, and background working could be not really too easy to understand for many developers, and we need to learn more about it, to read more about it, but we could work with it. I'm sorry, it's a problem in my slide. And what else? Kotlin Multiplatform still be improved. Kotlin native still be improved. We are waiting for a solution to the issue 462 and support of many dispatchers and more sophisticated work with the Coroutines and Kotlin native, and simplified work with background in Kotlin native side. And also we should wait for some improvement in flows mechanism, how to deal with it in iOS side, and to better interop with iOS SDK. But of course, it's really prospectful and interesting thing. So here is several sources, and of course there is links to sources with this interesting gist and article how to deal with flows and Swift combined publishers. Thank you very much. Thank you for listening. I'm ready for your questions.